Welcome to my channel. Today I will be speaking about tabular integration. Okay, this tabular integration is shortcut form of integration by parts. Sometimes this is called tic-tac-toe. Okay, now in this tabular integration method we have to choose as integration by part. Also we have to choose two functions. Okay, function 1 and function 2. Okay, similarly in this tabular integration method also we have to choose two functions. Okay, we call let's write d first. D stands for derivative, I stands for integration, and let's make some table like this. Okay, now over here how to choose d part terms, how to choose I part terms. Okay, now over here look at here. Now we have integral of x square into sine 4x. Okay, in this part, okay, this is what algebraic. Okay, now if I differentiate x square, it become a twice x. Okay, if I differentiate again, it become a 2. Again differentiation of 2 is constant, it become a 0. In certain differentiation this term become a 0. Okay, so in that scenario what we used to do, we used to select those terms which if we differentiate those terms in some steps it comes 0, then we choose those terms in the series of in the column of D. Okay, so here we'll write x in D column, we will write x square, this term, and since I already assigned x square over here, then sine 4x will come over here, sine 4x. Okay, with here sine will come here, with sine will be here, we can plus minus, it goes by plus minus and so on. Okay, now d by dx of x square is what? Twice x, and differentiation of twice x is become 2, and differentiation of constant is 2 is what? 0. Okay, now what about integration? Now we know that what we know, d by dx of sine of x is what? Cos x. D by dx of cos x is minus sine x. Okay, otherwise you can say d by dx of minus cos x is what? Sine x. Okay, means if integral of sine x become what? Minus cos x. Okay, similarly now integration of sine 4x become what? Cos minus cos 4x into 1 upon 4. Okay, why 1 upon 4? Because we have to differentiate 4x with respect to x again. Again integrate this. Okay, and again integrate this with respect to x. Integration of cos is what? Sine. Okay, here will be sine of 4x upon 4. Again 1 by 4 will come. Okay, 4 4s are 16. Okay, again minus. Now integration of we already have minus. Okay, integration of sine x is what? Minus cos x. Okay, so we already have minus over here. Okay, minus it become a plus. Cos, it will be what? Cos of 4x upon 16 into 4. Okay, why 16? This is already 16. Again we have to differentiate 4x with respect to x, the 4 becomes okay here. Okay, after this what we have to do, we have to do cross multiply here, like sending rockets from here to here, from here to here. Okay, this. Now this integral become what? This integral become plus, with plus sign, with this from here to here. Okay, it become what? X square. Here minus is there, so I will write minus x square cos of 4x upon 4. Okay, here minus plus. Okay, after this over here. Okay, now if you integrate over here, that will become 0. Okay, 0 into anything is become 0. That's why I didn't do integration over here. Okay, now here minus plus. Okay, plus it will be what? Twice x into sine of 4x upon 16. Okay, after this plus 2 into cos of 4x upon 16 into 4 plus some constant. Okay, this is the answer for this. Okay, in this tabular form, what we have to do is, first the main thing is what you have to decide. Okay, we have to determine in this column, okay, in this D column, what we have to choose. Okay, even in this I column, what we have to choose. Okay, this is the main category for tabular integration. Okay, I will solve some further integrations which in the tabular methods from which is somehow more advanced. Okay, now this question number 2, integral of x raised to half into log x dx. Now in these questions, look at here. Okay, we have x raised to half, we have two terms, x raised to half and x log x. Okay, now our target is what, which one we have to choose, in this D column or in I column. Okay, now here, now if I choose log x in integration, okay, now integration of log x is what we have to consider. What integration of log x is what, log x dx is what we have to consider 1, and again we have to use integration by parts, so it's very lengthy. Okay, it's lengthy stuff. If I keep log x over here, okay, that's why let's keep log x over here in this D part, and then let's write over here x raised to 1 by 2 as an integration, because x raised to 1 by 2 integration we can do very easily. Even differentiation of log x also is we can do very easily. Okay, now here let's write the differentiation of 1 by x is what, log x is what, 1 by x, and then 1 by x differentiation is what, x raised to minus 1 x raised to minus 1 means what, we have d by dx of x raised to n is n into x raised to n minus 1. Okay, here will be what, minus 1 into minus 1 is minus 1 x raised to minus 2. Okay, or you can say minus 1 by x square. Okay, again if I differentiate this, then what will come, again if I differentiate this, then minus 1 into minus 2 into x raised to minus 2 minus 1 is 2, minus 2 into 1 is, minus 1 into 2 is what, 2 x raised to minus 3 is what, here 2 upon x raised to cube. Okay, and so on. Okay, now what is integration? Okay, integration of x raised to half. Okay, x raised to half is what, integration of x raised to n is what, x raised to n plus 1 upon n plus 1. Here what we have, x raised to half plus 1 is 3 by 2. See, half plus 1 upon half plus 1 is what, x raised to 1 plus half is what, 3 upon 2. Here 3 by 2, so 3 2 will come up over here. Okay, so it's same as what, this is same as, I can write over here, integration of this become 2 by 3 x raised to 3 by 2. Okay, now if I differentiate this, so integrate this. Okay, if I again integrate, let's integrate this once again. I'll choose this again. Let's write 2 by 3 over here. Here I get 2 by 3 integration of this is what, x raised to 3 by 2 plus 1 upon 3 by 2 plus 1 is what, 2 by 3. 3 by 2 plus 1 is what, 5 by 2 upon 5 by 2 2 is a 4. Okay, here we can write over here 4 by 3, 5 into 3 is what, 15. Okay, 4 by 15 into x raised to 5 by 2. Okay, similarly keeps on going. Okay, now over here, okay, now over here look at, now neither this part or neither this part is getting 0. Okay, neither this, some other terms if we differentiate this, okay, it will keep on going. Over here if you integrate this also, it will keep on going. Okay, so we are not getting any 0 term over here, neither this side or this side. Okay, now in this scenario what we have to do is, now firstly we'll multiply this into this. Okay, with plus sign, with plus minus plus sign. After this, okay, after this, so you can stop at any time where your integrations where the term which you get, the integration will be easy. Okay, now if I multiply these two, okay, if I multiply these two, the integration of this is, we have algebra, base are equal, we can add the indices, so we can integrate easily over here. Okay, so in this, there for tabular integration, you can stop at any time where when you multiply these two terms. Okay, these two terms, the integrations look safe or less easy. Okay, in that you can stop over here. Okay, this case, okay, in this case here we'll multiply these two. Okay, now here this is same as this into this is what, 2 by 3 x raised to 3 by 2 into log of x here. Okay, this into this is, we have minus over here, minus integral 1 by x into 2 by 3 x raised to 3 by 2 dx. Okay, now let's remove this. Now this is same as 2 by 3 x raised to 3 by 2 log x minus, yeah, 2 by 3 I can send outside since it is constant, 2 upon 3. Now this 1 by x is same as x raised to minus 1, and this is same as x raised to 3 by 2 dx. Now if base are equal, we can add indices, means minus 1 plus 3 by 2 is same as minus 2 plus 3 upon 2 is same as what, 1 upon 2. Okay, this is same as, we can write 2 upon 3 integral x raised to half dx. Okay, why? Because if base are equal, we can add the indices. This plus this means what, minus 1 plus 3 by 2 is what, if I take LCM, minus 2 plus 3 is what, minus 2 plus 3 is 1 by 2. Okay, now is equals to, we have to write same over here, 2 by 3 x raised to 3 by 2 log x, here 2 by 3 x raised to 3 by 2 log x minus 2 by 3. Integration of this is very simple, x raised to half plus 1 is, I can write 3 by 2. Okay, this is okay, if you integrate this is this. Okay, therefore again x raised to 3 by 2 upon 3 by 2. Okay, 3 upon 2. Okay, here 3 is a 9, 2 by 3 x raised to 3 by 2 log x, 4 upon 9 x raised to 3 by 2 plus some constant. Okay, this is the required answer. Okay, now for this tabular integral, in this particular question, what we know is, what we should understand is, first, okay, now for D and I column, which term you have to choose. Okay, now why I am choosing log x in this, because if I integrate, if I keep log x over here, if I integrate, it will be very much lengthy. Okay, that's why I give log x in this side and then x raised to half in this side. Okay, now if you differentiate this log x again over here, 1 by x, and no here you cannot get 0 over here. Okay, similar integration also, it's keep on going. Okay, in that scenario what you have to do is, you have to stop at any time where if you can think. Okay, if you multiply these two either in this step or this step or this step, okay, if you find integrations looks safe or looks easy, in that time you have to stop. Okay, you have to stop and then you have to multiply with this. Okay, this into this with integral. Okay, this one. Now look at here. Okay, in this integral we have integral of e raised to twice x into cos x. Okay, this is very common. Maybe e raised to 3x, you can solve the same sum will be same as e raised to 3x, cos of 2x, cos of 3x, e raised to any power, sine of, it may be sine of x, cos of maybe it may be cos of 2x, all are same. Okay, the fundamental is what, now here. Okay, now if you integrate this, okay, if you integrate this also, it will keep on going. If you integrate this also, sine cos will go to sine cos will go. Okay, over here also. Okay, all the terms will keep on repeating. Okay, all the terms you can see here, sine will go to cos, after that cos will go to sine if you differentiate. Okay, in this scenario we have to stop. Okay, we have to stop at a time when you have matching term okay, or you can say if you have same terms, okay. Let's see how it works. Now you can choose anyone, okay, anyone D in the D part or as well as I part. I choose differentiation looks easy over here, so I will choose this e raised to 2x. Now integration part is what? I will choose that cos x, okay. Now d by dx of cos x is what we have? Minus sin x, and d by dx of sine of x is what? Cos x. Okay, but here will not be using over here, okay. So because I'm putting over here, okay. Now let's see. Now d by dx of e raised to 2x is what? D by dx of e raised to 2x is what? E raised to 2x into d by dx of 2x is what? 2. Okay, you have to multiply over here 2, okay. Again, if you differentiate this with respect to x, okay, again what? 2 into e raised to 2x. Again I have to differentiate 2x with respect to x, means 2 to the 4, okay. And again you differentiate this, 4 to the 8 e raised to 2x, and we'll keep on going, okay. Now look at integral part, okay. Look at here, you have all terms, you have e raised to 2x, okay, e raised to 2x, e raised to 2x with constant term, okay. Now integral of cos x, okay. Integral of cos x is what? Integral cos x is we have sin x, okay. Integral cos x become sin x, but okay, integral of sin x is what? Minus cos x, okay. Look at here, okay. Now e raised to x, we have all this repeated, okay. Now we are getting one repeated term over here, okay. We have cos x as well as we have cos x over here, okay. Now we have to stop, okay, the this tabular from when we have the matching term, okay. So let's see where to stop over here since we have matching term, okay. Now this is same as this into this with plus sign. We should have plus over here, plus minus and so on. So e raised to 2x into sine of x, okay, and then here, okay, and then this into this, okay, and then minus plus, okay. Here minus is plus 2 into e raised to 2x into cos x, because minus plus 2 is over here, e raised to x is over here, e raised to 2x is what? And then we have cos x, okay. Now since this term are same, okay, now we have to multiply with this and with integral, okay. Plus minus is minus integral. We have 4, okay. Here 4, I will write 4 here, e raised to 2x into cos of x, okay. Here on the left hand side what we have is e raised to 2x into cos x. On the left hand side we have, okay, this is dx, okay. Here dx, here also we have dx, okay. Now if I shift it from here to there, here 4 become, here minus become what? Plus, okay. This is same term, okay. This and this are same term, so here 4 become what? Here minus 4 become plus 4, okay. 4 plus 1 is what? 5 e raised to 2x cos of x dx. How come 5? Because we have 1, okay. This minus 4 become over there, it become plus 4 in plus 1 is what? 5, okay. Is same as e raised to, from here I can take e raised to 2x common, e raised to 2x sine of x plus 2 cos of x, okay. Now this 5 I can send down, okay, here, okay. Therefore this integral is same as this, okay. This is the required answer, okay. In this scenario what we have to do is, I will repeat again, you have to stop the time when you have the matching term or you have the same term, okay, for these DI methods, okay. It's integral, okay. Now integral we have 2x square plus 1 into sin x, okay. Now here which part we have to choose? D, which part we have to choose I, okay, for this tabular integral. Now if I differentiate these, okay, if I differentiate this first time, second time, after some time, okay, I will get 0 over here, okay. So it's better to choose this part as a D, okay. But for integration cos will keep on going. Okay, so I will choose this as a differentiation part. Why? Because after certain differentiation I will get 0 over here. Okay, here if I have 2x square plus 1. Now differentiation of this is what? 2 constant. Here 2 to the 4, 4x plus 0. Okay, okay. Again differentiation of 4x is what? 4 and 0. Okay, in some certain steps we are getting 0. Okay, now here sin x. Okay, integration of sin x is what? We have minus cos x. Okay, we have minus cos x. Integration of cos is what? Sin x. So minus will come here, sin x. Again integration of sin x is cos x. Okay, here integration of sin x is minus cos x. Minus plus cos x. Okay, now here we have to multiply this. Okay, this way and this way and this way. 0 into here, what will come over here? Here integration of cos is what? Sin x. Okay, here sin x will come. Okay, but 0 into this become a 0. Okay, now let's write down this equals to, it's very easy, this equals to 2x square into twice x square plus 1 into, here we have minus. Okay, here I write minus cos of x, this into this plus. Okay, here since we have minus 4x sine of x. Okay, and then here plus 4 cos x, and then plus some constant integration, this into sin x is become a 0. Okay, this is the required answer for, okay, this integration. Now in this integral we have x square plus 3 into e raised to 2x. Okay, now here which part we have to choose in this column, which part we have to choose in this column. Okay, now which we have to decide. Now in this x square plus 3, if I differentiate, okay, in some steps I will be getting 0 over here. Okay, now here if I differentiate, it will keep on going. Okay, even therefore let's choose this part in the column of D. Okay, so let's choose this part, means x square plus 3 as D part, and integrate this term. We have to integrate, keep on integrating e raised to 2x. Okay, now differentiation of this is what? X square plus 3 is what? Differentiation of x square is twice x plus 0. Integration of this is e raised to 2x upon d by dx of 2x is what? 2. Okay, again differentiate twice x with respect to x become 2. Okay, again differentiation of 2 become a 0. Now here we are getting, in some steps we are getting 0 over here. Okay, now it's in the integral part, here e raised to 2x, again integrate with respect to x, 2, again we'll get 2. Okay, 2 into 2 become a 4. Okay, here again integrate e raised to twice x, 4 to the 8 will come. Okay, now again if I integrate this, e raised to twice 8 to the 16. Okay, 0 be 0 0 over here. Okay, now this into this, this into this, this into this, this into this, here with plus minus plus minus plus sign. Okay, now this into this become a 0. Okay, now therefore we have to stop it at this term. Okay, now this is same as x square plus 3 into e raised to 2x upon 2. I can write 2 here, plus this is plus. Okay, here minus, we have minus twice, we have twice x into e raised to 2x upon 4, and then here we have plus 2 into e raised to twice x by 8 plus some constant. Okay, this into, but over here in the next term which we will get 0 over here, 0 into anything is 0. Therefore you can stop here. If you have, you can some generalize x square by 3, x square plus 3 into e raised to 2x upon 2. You can write like this. You can cancel 1 2 over here, minus x into e raised to 2x upon 2 plus here, if you can cancel here 4, e raised to 2x upon 4 plus c. Okay, this is the required answer for this. Okay, now integral of sec cube x. Now, okay, this we have to solve with the help of tabular integration. Okay, now over here, okay, look at here, sec cube x is now. If I separate, okay, this can be written as, can be written as sec x into sec square x. Okay, now if I use integration by parts over here, these are all trigonometric functions. Okay, now which one we have to choose? The first function is very difficult. Okay, now over here, look at here. Okay, now for this we need to understand some trigonometric identities. We know that 1 plus, we have trigonometric identities, what, tan square x equals to, we have sec square x, as well as d by dx of sec x is what, sec x into tan x, and the integral of sec x is what, log of sec x plus tan x. Okay, now look at here. Okay, now if I integral of sec x, now if I integrate, okay, if I integrate this, which one we have to choose? Okay, which one will be, this will be in this d part or this will be in I part. Okay, now if I differentiate this, okay, if I, what is d integral of sec square x dx? Okay, d by dx of tan is what, tan x is what, we have sec square x. Now if I integrate sec square x, I am getting tan x. Now this part is easy. Okay, now let's choose this part in this. Okay, and then this part over here. Okay, because differentiation of sec x is what, the differentiation of sec x is sec x tan x. Okay, so now this part I will choose over here. Okay, this part differentiation I will choose sec x, integral part sec square x. Why? Because integration of sec square is what we have, integration of sec square is we have only tan x. Okay, it's very easy. As well as differentiation of sec x is what we have, sec x tan x. Okay, differentiation of sec x is what we have, sec x into tan x. Okay, now integration of sec square x is what, integration of sec square is we have tan x. Okay, with here we have plus minus plus. Okay, now again integral of tan. Okay, integral of tan is, now it will be lengthy. Okay, we have to consider integral of 1 into tan x. Okay, now let's see over here. Okay, this can be written as, this into this, sec x into tan x. Okay, this into this. Okay, and then minus this into this. Okay, here minus integral sec x into tan square x dx. Okay, now what is tan square x? Let's convert. Tan square x is, from here you can say sec square x minus 1. Okay, this equals to sec x into tan x minus sec x, tan square become sec square x minus 1. Why I am doing? Because over here I will get sec cube x over here in this. Okay, since we have sec cube x, okay, therefore I am stopping over here. Okay, why I stop here? Because I know I will be getting matching term over here. Okay, now this is same as sec x into tan x. This into this is what we have, sec cube x. Sec cube x is on the left hand side. What we have? We have sec cube x dx. Now sec cube x, okay, dx, here minus plus integral of sec x dx. Integral of sec x dx is what, log of sec x plus tan x. Now this, okay, this, if I go this side, it will become twice. Okay, here become minus, become plus. 1 plus 1 is twice. This implies twice integral sec cube x dx is equals to, this become this side. Okay, now what we have sec of x into tan x here, plus integral of sec x is what, log of sec x plus tan x plus c. Okay, this is the required answer, or you can set this half over here, or therefore integral of sec cube x dx equals to 1 by 3 sec x into 10x plus log of sec x plus 10x plus c. Okay, you can keep like this. And now this integral x cube into e raised to twice x minus twice x. Okay, now this will solve with the help of tabular integral. Okay, or we can say tic-tac-toe. Okay, now the first function is what we have x cube, and second function is what we have e raised to twice x. Okay, for tabular integral, sometimes we call di also, di, we have to do this way. Now if I choose, okay, if I differentiate x cube, okay, after some steps I will get 0 over here. Okay, therefore I will choose in this part d, I will choose x cube. Why I am choosing x cube? Because after some certain differentiation I will get 0 over here. Okay, therefore now if I have chosen this, then this integral part I will do e raised to minus 2x. Now let's differentiate this. It's become 3x square. Again differentiate this, 6x, differentiate this, 6x becomes 6, differentiate this become a 0. Okay, now integral of this is what? E raised to minus 2x upon dy dx of minus 2x is what? Minus 2. Okay, again differentiate this with respect to x, integrate this, again this will be e raised to minus 2x. Okay, minus 2, again minus 2, minus 2, minus 2 is what? Again minus 2 will come, minus 2 is plus 4. Okay, again integrate this, e raised to minus 2x upon 4 into minus 2. Okay, 4 into minus 2 is what? Minus 8. Okay, again integrate this, e raised to minus 2x upon minus 8 into minus 2, 16. Okay, is plus 16. Now after this we have plus minus plus minus plus and so on. Now after send rockets, okay, now it is sending rockets from Ukraine to Russia, Russia to Ukraine. So same as send rocket, sending all rockets 0 to anything. Okay, now here x cube into this with plus into this, minus into this, plus into this, minus into this, 0 into anything is become a 0. Okay, now we don't have to write this part. Let's write this. Okay, this is same as this x cube. This we have minus 2 over here, so I'll write e raised to minus 2x into x cube upon here minus 2. Here minus, we have minus into this. Okay, here we have minus 3x square e raised to minus 2x upon 4. Okay, after this here plus we have, but we have minus. Okay, again minus will come here, 6x e raised to minus 2x upon 8. Okay, and then last here we have minus. Okay, here we have minus, I write over here, we have minus 6 into, we have here plus 16. Okay, plus 16, 6 upon 16 e raised to minus 2x plus some constant of integration. Okay, now 0 into anything is 0, so you don't have to write anything over here, and this is the required answer. Now this integral tan inverse x, I will write tan inverse, instead of x I will write tan inverse 2x. Okay, tan inverse 2x. Now this type of integrals, what we used to normally, we used to apply by integration by parts. With integration by parts we have islet. Okay, here we have, this is what? Inverse trigonometric function. Okay, here we have this inverse trigonometric function. This is same as what? This can be, I can write over here, this is same as 1. Okay, 1 into this, what we normally, what you used to consider, 1 is algebraic, so this become first function and this become second function. This is what normally we have algebraic over here, we have inverse trigonometric over here. Okay, so inverse trigonometric we choose first function, second function we choose as a algebraic, 1 as a second function. Okay, this is how we solve. Let me write down one step over here. By integration by parts, we have integral u v dx is u integral v dx minus integral d by dx of first function is u integral v dx and dx. Okay. Now over here, what is first function? First function is what? Tan inverse x. Okay. We have tan inverse x integral of 1 dx. Okay. Minus integral d by dx of tan inverse x and then integral of 1 dx is equals to tan inverse x, and this is what we have x. Okay, integral of dx is x, in integral tan inverse is what? 1 upon 1 plus x squared. We have here x dx. Okay. Okay, now here what we don't know is that d by dx of this is what? We have d by dx numerator is 1 plus x square. Differentiation 1 plus x square is what? We need 2. Okay. So we need 2. We have adjusted over here. Half same as x into tan inverse x minus half. This is what? Log of 1 plus x square plus c. Okay. This is a required solve what we used to solve with the integration by parts. Okay. Now for DI methods. Okay. Now for DI methods, what we will do is, we have what? We have D, we have I. Okay, tabular methods. Now your aim is what? Okay, I already solved by x. Okay, so I'll solve by x only. So, twice x, tan inverse twice x, and twice x or tan inverse to x or x tan inverse it twice x or tan inverse x, 1 and 7 logics are. Okay. Now differentiation. Okay, now differentiation constant become what? 0. Okay, so I cannot take 1 over here. Okay, why? Because differentiation constant becomes 0, so I have to write here 1. Okay, and then I have to integrate this. Okay, and then over here we have tan inverse x d by dx. Tan inverse x is what? 1 upon 1 plus x square. Now differentiation of this is what we can say. Here this can be written as 1 plus x square raised to minus 1. Okay. Differentiation of this is what? Minus 1. 1 plus x square raised to minus 2 into d by dx of this is twice x. Okay. This is differentiation of this. Okay. Here this is differentiation. Okay. Now integration of x is what? We have x. Integration of x is what? X square upon 2. Okay. Now what we can do is we have plus here, minus here, plus here. Okay, we have plus, minus, plus. Okay, this term is over here, bring over here. Okay, now here we can stop over here. Okay, now if I multiply these two, okay, and then integral, I'll get a quick answer. Okay, so therefore I'll stop over here. This we don't require. Okay, now this is same as, this can be same as, this is same as this into this. Okay, we have plus, so x into tan inverse x, we have minus. Okay, we have minus into this. Okay, minus integral x into 1 plus x square dx. Okay, this is same as x into tan inverse x. Same way we have solved 1 by 2, it becomes log of 1 plus x square plus c. Okay, this is the answer.